This is activity number 2 for lesson A-18. For this activity, you will need the assembled Raspberry Pi setup with the completed circuit you built in the last activity. In this activity, you'll use the circuit you just built in the last activity and write a program that will illuminate an LED with a 1 to 5 second delay, start a timer when the LED turns on, stop the timer when a player presses a button, and display who pressed first and that player's winning reaction time. In this program, you will be talking to GPIO pins using the time sleep command and the random int command. Go ahead and open Thonny and start the program by loading the appropriate modules. Next, set up your board numbering type and GPIO pin assignments. Configure the GPIO pin assignments. GPIO 26 will be the output for the LED. GPIO 20 and 21 will be used as switch inputs. Now, you could turn on the start LED as soon as the program starts, but instead add a random delay to randomize the number of seconds to delay before the LED turns on. Assign a random integer from 1 to 5 to the variable called wait. Use time sleep to sleep for an amount of seconds equal to the wait value. The first statement will create a variable named wait and set it equal to the value of a random integer starting between the starting point of 1 and the stopping point of 5. Now that a 1, 2, 3, 4, or 5 has been randomly selected for the value of wait, you can call the time sleep command and specify a delay in seconds equal to the value of wait. Now that the random wait has ended, it's time to turn on the start LED and start a timer. You can turn on the LED by pushing GPIO 26 high. You can start the timer by making a variable called time start equal the current value of time.time command. Now that the LED is on and you have stored the current time, make a while loop to check for a winner. Create a variable called winner and set it equal to no. This will allow you to continue running the program until there is a winner. Next, create a while loop that will keep the while loop running until a button is pressed. The contents of this while statement will continue to execute as long as winner equals no. If winner equals anything other than no, the loop will be skipped and the remainder of the program will run. Add some if statements to the while loop so you can modify the value of winner based on which player pressed their button first. Player 1 will be assigned to GPIO 20, which is connected to the switch closest to the wedge. Player 2 will be assigned to GPIO 21, which is connected to the switch furthest from the wedge. Each time the while loop is executed, the if statements will be checked for truth. If input GPIO 20 is high or true during the check, then the winner will be set to player 1. If input GPIO 21 is high or true during the check, then winner will be set to player 2. If neither input was high, then the value of winner will not be modified and the while loop will run again. Be sure to double check that your code indentation is correct or the loop will not run properly. Build the code that will run once a winner is determined. First, create a variable called time total that will be equal to the current time using the time.time command, minus the starting time that was stored in time start. This will take the current time in seconds and subtract the previously stored time start value in seconds. The result is the number of seconds between turning on the LED and player 1 or player 2 pressing a button. The value of the number calculated in the last step is a very long number, like with 10 decimal places. No one needs that kind of precision. You can get this into a more display-friendly format by removing all digits past the thousandths of a second. This code will take the value of time total, remove everything past 3 decimal places, and save the result back to the time total variable. So the very long number you see will now become 1.284 or something similar. Now you have a reaction time that can be displayed nicely in a print statement. Now that there is a winner and a reaction time, you can build some print statements that let you know who won and what their reaction time was. The first statement will print the value of a winner with a blank space and wins added to the end of the string. A single space has been added before the word wins in order to ensure correct spacing between player 1 or player 2 and wins. Now, without the additional space, you'll end up with player 1 wins or player 2 wins smashed together in your console output. The same behavior can happen in the second statement with was and seconds. There are extra spaces there to properly space out the words. Now that you've printed the winning player and their reaction time, turn off the LED and clean up all the GPIO pins. This allows the program to exit gracefully. Verify the fully assembled program is free of errors. Find a friend or a family member who will be most impressed with the skills you've gained during Level A of this course and play the game with them. Remember to let them win occasionally, okay? And be sure to save this program for future game playing or to modify it in the future as your skills develop further. Congratulations! You have completed the first level of the Intro to Robotics program. You've learned quite a few new electronics and coding skills and should be able to tackle beginner level Raspberry Pi and Python projects you find online. Now, we recommend moving on to start Level B of this program. In Level B, I'll teach you to use increasingly complex electrical components, including a variety of sensors, and we'll move on to intermediate level Python coding. I hope to see you there.